My name is Anthony Lai-Ferrario, product manager at Pure Storage. I've been at Pure for about 5 years in a variety of roles across product management and engineering. And I think today we're going to hit a bit of a hybrid across both of those roles from my perspective on Pure Fusion. So the first topic I want to do is getting into providing storage as a service to developers. So this is really about building these storage services that we've spoken about with Pure Fusion in the past. So let's get into it. Before I do that, I just have to hit the typical legal disclaimer that we're making future statements here. Fusion is not a GA product yet, so please take that into account as we go through this talk. Just to quickly cover, Fusion at a high level, right? We're doing self-service, autonomous storage as code at limitless scale. That's a bunch of big words in one sentence, but the simple touch point here is we're driving a cloud operating model anywhere. And we're doing it using a combination of front-end self-service provisioning model, as well as back-end workload management and scale-out technology. So let's get into some of the details of that. One thing that's really critical when thinking about Pure Fusion and getting into really how it operates and how it works is that we have a distinction that's not typically been made in the storage world, and that distinction is between a provider and a consumer. So where the provider is probably a typical IT role of some kind, storage engineer, manager type person, they're now responsible for defining services, right? Defining storage services that are going to be provided out into the environment, rather than worrying so much about the day-to-day care and feeding of individual systems. These folks in the Fusion model aren't expected to own the applications directly, and are expected to care about the layout of the infrastructure, whether that be truly physical in an on-prem world or virtually physical in a cloud type environment. Now on the consumer side, what we expect here is these are really the consumers of IT infrastructure who do not care about the arrays. All these folks are interested in is their applications and the business value that's being driven, right? And this is someone who needs, in our mind, right, and in the Fusion model, interact with storage in a much more cloud native fashion and not in a traditional, I need to know about this box that gives me a LUN type of fashion. So this talk is going to really be nuts and bolts on what Fusion is, how the object model works, and how you'd go about thinking about providing these services out to those consumers. So what I've got here at a high level is our object model. I'm going to dig into each part of this separately over the coming slides. But the thing to call out is we have 3 core types of objects. We have provider objects, which is really the infrastructure side. We have policies, which the providers are generally creating and surfacing to the consumers. And then we have consumer side objects. And this is really what you're interested in if you're going to come in and consume storage from a Fusion system. So, these are the sort of high level categories. And we have appropriate, user capabilities that are associated with these different objects. So to start with, Larry mentioned that we operate a availability zone concept in Fusion. So when you think availability zone, definitely do take a lot of the inspiration from what the public cloud thinks of when they talk about an availability zone, but then we need to layer some additional detail in here. So our availability zones sit underneath a concept called a region that we have. That region is a logical grouping of availability zones intended to indicate geographical locality. There's nothing too dramatic there, but in terms of helping those users understand what they're getting, regions are very critical, right? The availability zone itself has 2 sides, right? It has the underlying infrastructure, and then it has what it's promising to end users. On the underlying infrastructure front, the availability zone is represented by a set of arrays. These could be physical arrays in our FlashArray//X family, FlashArray//C family, XL, our newly announced high-end product, or it could be our Cloud Block Store family products, right? So it could be cloud-based, or it could be on-prem. Both work under the same concept. Now, from a networking perspective, the idea here is that this really is the sort of scale-out cluster peer concept in our model, right? What the expectation here is that while end users, consumers will address the AZ through well-known addresses, the AZ under the hood, is all going to be coming from a pool of additional addresses that we are going to be managing and handling.
Yes, sir. I have to be careful talking about scale out because typical scale out systems, if you have systems that fail, you can usually get to one cluster storage one HA pair storage from another HA pair. We can't do that here. There's just still all autonomous arrays, right? That are not, right? There's a management scale out, but not a data path scale out.
So it'll depend on exactly the way this gets implemented. In the typical case though, yes, that is the way it works. The way I'd like to think about it is, I like to think of an AZ as a storage system as a whole. That storage system is expected to offer things like data protection capabilities, volume capabilities, so on and so on. The difference about this storage system is that it has different uptime and availability characteristics than our traditional physical systems do, in that we could lose access to some subset of the data served by this system without losing access to all of it. So I like to think about it as a storage system that has a different set of availability characteristics in exchange for wide scale. Now,
that doesn't necessarily make them better availability characteristics, though, does it? Because you've got more components which could fail. And depending on how you choose to deploy it to the client could have lots of smaller systems, or it could have a smaller number of larger systems, which would instantly change their availability scenario, because the scenario of failure would be different at each time. But they wouldn't necessarily know that. So how are you going to guarantee that, for instance, if you were building this into an as a service model, that you're not breaking the level of availability the customer thought they were getting by changing the back-end infrastructure?
Yeah, so there's two parts to that. Number one is we actually distribute the management capabilities of the availability zone across the systems in that availability zone. They don't run as a single point of failure. So from an availability zone uptime perspective, we have significant redundancy there. So in terms of access, I don't necessarily worry about it. In terms of the SLA for the individual storage, we would offer the same SLA there that we would if it was one of our 6.9s devices, right? So the way I would say it is, if you provision storage on the AZ, you should expect 6.9s availability. And whether that's a widely scaled AZ or a very thinly scaled AZ, you should still get the same characteristics there.
One of the things to consider here is that, so while the consumers in a Fusion environment don't directly have access to the back-end arrays and they don't see individual arrays, there are certain objects in the object model that expose the storage to them in such a way that we keep their workloads in place. So we're not going to just randomly distribute their volumes in any random fashion in the AZ. They have the ability to understand what kind of layout they want and ask for that sort of layout in the environment.
And ultimately that was my point, because if you've got an application that's got 100 volumes, sorry, I'm not sure we're supposed to use the word LUNs anymore. Now we were discussing that. If you've got, say, 100 volumes and you've got them distributed across multiple platforms physically, then you've got an increased risk of failure of that application, not necessarily of an individual piece of hardware, but of the application you have.
Yeah,
that's a great point.
Unless you're grouping them together, you're going to get a problem.
It's a great point. And I'll talk about what grouping constructs we have available for application architecture. Yeah.
In this picture, again, there is no indication of the fact that you can operate the system in parallel through the two, models and mechanisms to avoid confusion. In the sense, a system administrator that deletes a LUN or a volume without the Fusion knowing or
Yeah, so that is something that we're planning to build in support for Fusion in what we call a sort of dual mode operation with traditional flash array access. That's not coming as a part of the initial product launch, but we definitely know that that's a real use case. And the way we're looking at doing that is basically cordoning off objects which are owned by the Fusion management paradigm and sort of making those things not interactable for a user coming in through sort of the underlying FA interfaces. And the way we would look at that from a load management perspective is very similar, right? Because the workload planner capabilities that we get from Pure One take into account all the load that's happening on the array. So in terms of workload placement, in terms of migration, we will take into account dual mode use cases when we release that.
Okay.
Yep. So talking about networking, how do we actually hide this from people, right? Because the consumer is not supposed to have to know about this, right? We have two key things that we use. One is called the storage endpoint. The storage endpoint is a set of IPs that are associated with your availability zone that are well known. These are published to consumers, and these are the IPs that the consumers configure in their servers. And these are unchanging over time. They're unchanging as workloads move around. And so the end user, the end consumer doesn't have to reconfigure their storage as we move along. The way that works is that we actually do redirect on login in iSCSI, and we point the server actually down to one of the interfaces in an underlying network interface group. So the way we would explain this to a consumer is we would say, here are the IPs to program into your server, but here's the range that you need to have reachable. And so that way, as we do the underlying management of the system, that doesn't have to impact the end user. So those are the core concepts that we do within the visibility zone for networking.
So redirected login's fine if you're using iSCSI, because once you've actually redirected, you've got a path to the device.
Yep.
If you tried to do the similar thing with fiber channel, I can't see how you'd make that scale, because you potentially have got multiple interfaces at the back end of each device, each server, sorry, each storage server, and then you scale that across many, many devices.
Yep.
The only way I can see you can do that is through a Lua, which means that you'd end up with hundreds of paths, and the host multipathing software would get massively confused unless you've got some way of managing that multipathing environment.
Totally. So let's talk about this one later. We have iSCSI for our initial launch of the product, and we do plan to bring a fiber channel version, but I can't speak to that at the moment.
Okay.
So in terms of the underlying arrays and how that maps into the Fusion model, what we have is we have basically parallel objects to what you might expect. We have a logical array concept, and we have network interfaces. So these network interfaces end up being provisioned on those network interface groups that I mentioned in the AZ, and this is how we manage the data addresses that workload gets forwarded to, and we make sure everything lines up from an access perspective. So nothing too dramatic here. So with that, that's sort of the core set of physical layer objects in the Fusion object model. Here's what a topology might look like, right? We want to address the fact that customers may have, multiple sites. They may have different quality of links between those sites. They may have public cloud operations going on, right? So this is sort of, a simplified view of what a customer deployment might be. If we take the model that I was just talking about and we overlay that here, what you'll see is we end up with regions being representative of the large physical sites, right? And within those, we break down multiple availability zones based on whatever networking or physical availability layout the customer storage team wants to implement, right? So the idea here is we're not being prescriptive in terms of how someone lays out their environment. We're instead trying to provide the primitives so that whatever environment layout they have, whatever services they want to offer, they're able to represent that in Fusion. And that works equally well in the public cloud. So in the public cloud, I would typically expect these to line up well with the public cloud concepts, region and availability zone that are already there. But if someone wants to implement a different structure, we have the primitives to support that. So there's no reason that region 2 couldn't stretch across these two sites if you had a low enough latency link here. The key thing is that if you're going to, co-locate storage within our object model, you're going to have to be low enough latency to support those migrations. And under the hood, that's taking place using our active cluster technology. So we need a low latency link for that.
I can see that the two bottom ones are data center B, and the top one's data center C, and there's a medium latency link up there. Does that suggest asynchronous offsite replication?
It does.
Okay.
It does. So the intent here, right, is to show that, what we do in terms of Fusion and how we support regions is going to support multiple replication modes, multiple sort of relationships between those different availability zones and regions. Yep. All righty. So with that in place, right, we pivot over to how do you then expose this environment that you've put together, right? And the way we want to do that in Fusion is we want everything to be defined as policy. I even like to sometimes say that everything we've talked about so far is actually a location policy, because all you're saying is I have certain location and networking expectations. You make the decision, Fusion. But that's me taking it to a logical extreme rather than necessarily the way it has to be. But within our model, we also have a bunch of policies that are defined that the user needs to use to get access, right? So the first one is storage service. At a high level, a storage service represents, the expectation users would have of a type of storage, right? So what network protocol does it speak? What are its uptime characteristics? What technologies does it have access to? As we expand the platforms under Fusion, this is going to be very heavily used for that kind of a thing. Underneath storage service, we have storage classes. And storage classes are the way we do performance allocation, right? And bounding that, right? So you can think about IOPS and bandwidth limits and even capacity limits. These kinds of things fit into the storage class. Host access policies. So host access policies actually can be defined on either side of the fence, depending on the model that the customer has, whether a user is bringing their own VM or whether the infrastructure is predefined. But the idea here is you're defining access policies based on the addresses that the individual hosts have, and you can assign that to a storage request as a consumer, and that's how we manage access to those volumes. The last one here is an intent-driven sort of SLA-based way to define protection. So instead of defining a relationship replication link between two, physical storage systems and, adding your volume into some object, what this is saying, I have a certain SLA I need. Let me assign that to my volume, and Fusion will take care of allocating that. So all of these are definable by the provider. So similar to the way I was talking about the topology layout being provider defined, all of these policies are also provider defined. So Fusion gives you the primitives, you implement your service. So in terms of the consumer side, right? How do you support those consumers and what's the tenancy model? So we have two layers of tenancy here, RBAC essentially here. The highest level is the tenant. So the tenant really represents something similar to a customer, if you will. If you imagine a managed service provider type environment or a cloud type environment, this is really the customer. This is the highest level grouping. Within that, we have another object called tenant spaces. These tenant spaces are actually defined by the consumers themselves, and we typically map those to an application within the consumer's world, right? So if you have a specific application, you're going to provision a tenant space, and you'll get access to a lot of nice grouping capabilities and management capabilities within that.
So can we see a tenant as being, say, a line of business, or
inside of an enterprise, for sure? Yeah.
Okay. So something where there's a collective similar set of requirements, or just simply a financial billing, or could it just be any of those things?
Absolutely. Yeah. I mean, one joke would be, you could label your tenants billing code 1, right? That's definitely one use case we anticipate for.
When things are in when a tenant space is in a tenant, is that a one-to-one inclusive mapping, or can you Venn diagram overlap them? Because imagine some applications could span multiple business groups and therefore might not be able to sit in two different tenants at the same time.
So right now it's a hierarchical tree mapping. Definitely hear people asking about concepts like that. So we'll see how we address cross-tenant access needs, but generally, yeah.
I mean, I know it may seem like a silly question, but I'm sorry. Go ahead.
You just mentioned enterprise, and I was just wondering. Most of the time, multi-tenant seems to be geared towards SMB, and I also noticed that you guys were only listing AWS and Azure as the cloud platforms that it's supported on. So I'm just wondering, is this focused on SMB?
So in my experience talking to customers, there are two places where this has been extremely exciting. One is in the traditional MSP, SP type use case where those folks are selling to SMB, and those SMB users might be tenants in the system. Another place that we've found it to be very popular is in the very large enterprise where they want to operate their own IT as an internal cloud. And something like this is very well aligned with someone defining those services. And just to address the supported platforms, right now, Pure Storage offers our Cloud Block Store offering in Azure and AWS, and that's the basis for Fusion being available in those environments. So as Pure expands or as we bring in the support for additional platforms, that's what's going to unlock access to those environments for us.
Do you provide any mechanism for chargeback for the tenants?
So our approach to this is that we think the way people implement chargeback varies incredibly wildly. So what we're looking to do is to implement showback systems where you can calculate and show metrics, usage, all these kind of numbers at useful rollups in these tenancy models, rather than directly implementing here's a bill system.
Okay. Well, the question I had, that may seem like a little bit like a silly question, but how does this compare? Obviously, it's going to compare favorably, but today's experience of say MSPs that run Pure, lots of Pure. I see this as a great MSP play. I personally know of service providers that serve out Pure to all their clients.
Yeah.
In especially like Oracle environments, things like that.
Totally.
How does this compare to what they have to do today? Like how do they deal with this today? And how does this solution solve those problems?
Yeah, absolutely. So basically today, in order to operate, pure flash arrays without the Fusion management model in a truly multi-tenant world, those end users cannot interact with flash array because flash array itself today is an undifferentiated large pool of storage, right? And so what that forces an MSP to do, and this can be okay depending on the exact model that the MSP uses. For instance, if it's VMware VMs as a service, this is obviously not that big of a deal, but it forces that MSP to gate access to the storage layer and to really own that and build, maybe not exactly Fusion, but something along the lines of Fusion to handle allocation, distribution, workload migration, capacity management, all this kind of stuff, right? So essentially they either have to rely on something higher up the stack to hide the storage layer, or they have to implement something like this themselves.
Or do it manually.
Right, which we're trying to avoid.
Okay.
Do you see, Fusion applied it to Pure as a service? So thinking more about the service level objective, not providing the infrastructure as a service.
Absolutely. I hope Pure as a service is our biggest channel, right? The way I look at this is, Pure as a service, is a business construct and a way of delivering storage today. What I'd like to do is I'd like to pair the Fusion management model with Pure as a service, so that we can move further and further towards the flexibility as a service consumption model that type of customer wants. So I absolutely think they line. Now, that's not to say that CapEx purchases of arrays doesn't work with the Fusion model. It's just that in terms of billing and consumption, lining that up on a as used basis makes a heck of a lot of sense with something like this. Yeah.
Okay.
All righty. So here's where we get to that grouping object, and hopefully we can address the question from before here as well. So within a tenant space, we have a really important object here called a placement group. So this placement group has a bunch of capabilities for us. Number one, it's the hardware affinity and anti-affinity grouping. So if you're worried about something where you don't want an application to have exposure to multiple failure domains because you're worried about a situation like was described before, this is a great way to do that. So if you want to make sure you're going to have all of it in one place, you can do this. If you're operating a distributed application, the simple answer is additional placement groups, right? So as wide as your application wants to go, you can provision additional placement groups. Now, if there are not enough hardware domains in your availability zone, you are going to be limited on that. But in general, right, this allows distribution of the workload across an availability zone. In addition, this is one thing that really helps folks trying to operate more traditional applications in a more modern model. So we got the question about dual mode access earlier. This is one way we're hoping to encourage customers not to try to operate that way. Because if you need things like crash consistent snapshots, that's also going to be available in this placement group object, right? So without exposing the underlying arrays to the end users, we give them a way to understand co-locality, right? So if you look at what some people in the cloud do, they offer spread placement groups or other things. This is a parallel concept for us. Another thing this aligns with is the storage service. So if you're going to be provisioning against very different types of storage, you can target your placement groups towards different storage services, right? And within those storage services, you then select your storage classes. And that makes choosing that very straightforward. In addition, this is the rebalance granularity. So I'll get into the exact rebalance case in a little bit here. But the beautiful thing about this is, since the tenant is understanding their co-locality at this granularity, if this granularity moves as a unit, that doesn't impact the application layout and architecture that the consumer has expected. It doesn't change what they've done, but it allows the providers to manipulate and manage the environment. So this is a super important object for us. This is actually also the layer at which volumes are bundled together and surfaced through IQNs, if you are interested in the details. So that's the whole model, basically. What I've got here is a breakdown, a logical environment, right? So this is, more or less a fully deployed environment that has all of our different objects. We've got several tenants lined up across the top, consuming storage. We've got multiple tenant spaces in each. different placement group layouts, different volumes that are being targeted towards different things. And under the hood, we can see we've got a couple of regions broken down into availability zones with different types of arrays in those regions. And we can see we've mapped all of the placement groups down to that underlying storage. So the idea here is that all of these represent different use cases that we're trying to support with this set of primitives that we have in Fusion, right? So if you look at production and reporting copy of an application in the same availability zone, what you'd see is these two sets of volumes, one targeted here, one targeted here. The end users don't know which array those are. They know they've targeted a storage service. They know they've targeted an availability zone. That's all they worry about. So,
and are these all static at the moment in terms of once you've actually set that definition up, that's it?
Not necessarily.
Okay.
So all of this is modifiable by users, right? So it depends what you mean by, is it static? It's not actually static. Sorry, go ahead.
I'll explain what I mean by that then. That's fine.
Sure.
I'm thinking that you've now given me a great layout. I've got all my applications in a certain place.
Mm-hmm.
Then I decide I want to do something different, move something somewhere else, pick up a whole chunk of stuff, put it to the cloud environment or move it to another data center, maybe a less resilient data center because it's not as important an application or something like that. Can I just pick up that tenant group or, the deployment group and say, move that whole object to another availability zone rather than just within a single tenant?
Yeah, that's the intention. Yeah. So the idea here is, and I'll get more into this later, but the intention here is this is all declarative. This is all API driven, right? And so if you want to change that, just change it and we'll find a way to make it happen for you.
And sorry to ask another question, but,
that's all right.
But that implies that you end up with a difference between desired state and active state. So you could be in a position where you've got a desired state implementation of where you want everything to sit, what level of availability you've got, but there's also the risk that you might not actually be able to deliver that on the infrastructure that's on there at the present time. And that might not be because you did it as part of the creation of those tenants. It might have occurred because of hardware failure or other scenarios. So how do you prioritize something when that happens, and how can you sort of spot that within the GUI?
Yeah, so let me address it briefly here, and then we'll talk more about it later.
Okay,
but the simple answer is the way Fusion views the world is last known good state. That's its central understanding. We also track outstanding operations that are happening as tasks. And basically what you would do is and depends how you're implementing this, whether you're looking at our GUIs or whether you're implementing this, integrating it into a portal system. But what you can do is you can look at outstanding tasks which align with things you've asked for, right? And those outstanding tasks will give you status, right? So as you work through these, you can always tell whether something you asked for is done or not. And that's the way you'd manage that. There was another piece of that.
It's really just looking at it and saying that I'm now not meeting the SLAs that I've expected because of the quality of service and everything, because a component of hardware failed or something like that. How do I see that I'm out of expected QoS or out of expected?
Yeah, so that's a question that probably requires a lot of specifics, but the general answer is we'll support a similar alerting structure to what we've always supported in Pure One.
Right.
And so if you start to see degraded states in the environment, that'll be surfaced through those alerts. But we would probably have to get to a use case by use case breakdown to really address those. Yeah. All right, so let's talk about rebalance. What does rebalance look like? So what I've done here is I've cut out a bunch of that previous diagram and I've zoomed in, right? And we've got tenant A, and they're laid out across two underlying availability zones in region 1. Here's a typical scenario that might happen. This other workload, which is coming from some non-tenant 1 tenant, right? This additional workload is driving, way more performance consumption than it has been for a while, right? And so what happens is that puts one of the systems in availability zone 1B under pressure, right? And while this doesn't necessarily immediately translate to visibility to tenant A, this puts those SLAs at risk, right? So what happens here is the consumer will get an alert similar to what we just talked about, that an array is under pressure, or this could also equally be an array that is starting to have some hardware issue or some other issue, right? What we do then is the provider basically can reach out to an individual placement group and redirect it to another underlying array. This is simply done by a patch API call on that placement group to choose another underlying target for it. So there's nothing complicated. It's not a many-step manual process. It's just a redirect. Under the hood, Fusion will use Active Cluster, which is our active-active synchronous replication technology, to stretch that storage between the two systems. And we'll use the iSCSI redirect that we mentioned earlier to fail the paths over. And of course, we'll be careful that we're not failing you over into something you can't support, right? So we're careful about that. But as we do that failover, you're continuing to have access and you're continuing to maintain the same server-side configuration throughout the entire process. And then once completed, we unstretch that storage to that second system. And critically, right, the tenant's configuration remains unchanged and the provider is able to take load off of the underlying array. That's the high-level rebalance.
So that's essentially the noise neighbor problem.
Yes.
That you're dealing with there. How do you avoid that movement becoming a noisy neighbor itself?
So the way we do this is before we move, we make that movement, we make a call to our workload planner APIs in Pure One Meta, and Pure One Meta will do an analysis of all the possible array targets that this could be moved to, project the workload based on adding this set of volumes to that array, and give us a prioritized set of recommendations for where to put that load. We will defer to the provider if they want to make a choice, other than number one on that list, but that's the approach there.
Does it take into account the noise it will cause on that already noisy array?
Yes.
Okay.
Yeah.
But what happens if you have one of these workloads that change continuously in one of these arrays? So it goes down and up and down continuously. So does Meta One takes into account that you could have a spike in 30 minutes or 1 hour?
Yeah. So Pure One Meta is not a static checkpoint analysis tool. It looks at, I forget the exact time range. I need to double check with that team, but they do look at the workload history there when planning, when doing their workload planner migration suggestions.
So if you expect that something will change in the next, period of time, then you don't move the workload anymore.
Yeah, it's trained. So that system is trained on basically all of the existing workloads that we have. So we're, that there's plenty of workloads that exhibit, time-based variation in that subset, in that training set. So
okay. Makes sense.
All right. The way this is managed, we have a management GUI. It'll be hosted in Pure One, which is our cloud management system. So regardless of where you run your Fusion-based fleet, your management will always be accessible through Pure One. In addition, for the API, since this is sort of both a system aimed at the traditional sort of storage administrator as well as fully integrated environments, we offer both a CTL command line tool. Think about kubectl if you're looking for the inspiration there. We also offer, of course, SDKs and infrastructure as code integrations if someone wants to integrate this into their environment. I expect the integrated environments to greatly outstrip the manually managed environments, but we want to support them both.
And how are those integrated today into things like Portworx? Use that.
Yeah, so in terms of Portworx, we don't have an integration yet, but what you can think of, right, is if you look at the way Portworx supports cloud volumes, you can see the direction that we're going to go.
And where does Fusion run and how much resources?
Yeah, so good question. Good question. Fusion operates in two different places. One is it operates as a distributed application running on the underlying appliances in your fleet, be they public cloud, be they private cloud. And that's really for the data path management stuff and local management commands, right? So the idea here is that means that no matter whatever happens to any other connections you have, your IO continues to flow and so on, right? The rest of Fusion runs in Pure One Cloud and is accessible through our cloud endpoints. So that's required if you're going to do policy definition, state change, that kind of stuff. Yep. So in terms of impact on the arrays themselves from a performance perspective, since we're not in the IO path from an ongoing IO perspective, there isn't any expected change in performance there. And the local agent is very light. So that's not a significant performance concern.
Worst thing that can happen is that you lose the connection to the internet where you have the control plane.
That's right. That is the worst thing that can happen.
The workload management aspect of things wouldn't happen as well, I would assume.
That's right. That is driven through Pure One workload APIs. That's right. Well, let's take a quick look at a demo here. Basically, what I'm going to show is a provider walking through CLI-based operations to define some policy and then switch over to a tenant perspective to do a quick workload provision. These APIs are not the final APIs, so when we get to production, there will be some differences, but this is still representative of what we're doing. So what we're going to do first is we're going to provision, or we're going to check out what infrastructure is deployed. So we're going to look at what availability zones there are. We can see we've got 2 availability zones coming back. Pure Zone 1, Pure Zone 2. Obviously, this is in one of our own environments. You would expect this to be different in a customer environment. We're looking at what arrays are in those availability zones. So we've got 3 arrays provisioned in our availability zone, just taking a look at that. That's deployed infrastructure in Fusion. The next thing we're going to do is define a storage class. So we're putting in IOPS, we're putting in bandwidth limits, we're putting in a volume size limit, and we're associating it with an underlying type of storage. We create that. And then based on that, we've now got enough infrastructure there that the consumer could provision workloads. So we're going to switch over to a consumer profile, and then we're going to keep going forward with this. So switching to a tenant admin profile here. And then we're going to create a tenant space. So the idea is now that this tenant admin has access to their infrastructure, they're going to create the tenant space, which will contain their application. That creates very quickly. Now, within that tenant space, the next thing we need is a placement group. So as we mentioned, that placement group is really where that workload is going to live. And it's the co-located guarantees, availability, affinity guarantees that we talked about. So next, we're creating the tenant space. We're creating the placement group. And then from there, what we can do is we can look and say, okay, what storage classes do I have available as a tenant? So we listed out the storage classes. We can see the 3 that we've got available here. We'll select one and we'll use that to make a volume request. That volume request will consist of the tenant space we want to target, the placement group in that tenant space we want to target, the storage class, and what availability zone we're going to be targeting. And given that, Fusion has enough information to provision the volume that we want to create. So we just put in a volume create command there. The next thing we need to do is we need to check what hosts we have available. So I'm going to look at the host access policies that we've got. And we can see I've got a Linux host access policy for a Red Hat machine that I have. And then I'm going to basically assign that host access policy to the volume I've just created. And that's the end of the process from an end user perspective. That end user was able to request the storage they needed in the place they wanted, with the characteristics that they wanted, and get access to it without worrying about any of the underlying hardware. So that's it in terms of a simple walkthrough. What we did was we looked at what infrastructure we had. We created a class, we exposed that service. We turned around, we came in the front door, and we created a volume to meet the needs of some consumer use.
Isn't there a massive security challenge? I mean, you know, how are you managing the volume security, not the volume security across devices, because you've got a real issue there.
Yeah, so there's 2 different ways we're addressing that. One is we're going to allow CHAP configuration to be included. Now, obviously, CHAP doesn't solve all problems, but it is a nice step in the right direction. The additional thing we're doing is we're allowing specific networks to be created and assigned to those AZs and exposed to different tenants. So you'll have separate VLAN tagged networks that you can assign.
And is the definition of CHAP within your API?
It will be. In this version of the API, it's not there.
Okay.
Yeah.